evening. I'm Laila Ziko, adjunct assistant professor at the biology department at the American University in Cairo. Let's imagine the days back around World War II, where they were really sad days. If a person gets wounded and just got a bacterial infection, they would die. But then when penicillin was discovered and later antibiotics, they literally saved millions of lives. And now the world is actually scared that these sad days are about to happen because of the antibiotic resistance issue. One of our major findings in my PhD project was that we detected antibacterial and anti-cancer effects from microbes living in deep Red Sea areas. So to take a general overview, the 1950s was the golden era where a lot of antibiotics were being discovered from nature, but in the 70s, scientists went more to chemical synthesis. In the 90s, sadly, Big Pharma stopped funding this area of research. They stopped looking into nature for antibiotics, and sadly, in the same era, superbugs are now on the rise since the 90s. But now, through new sequencing technologies, genome sequencing, scientists appreciate that organisms, including microbes, they have a huge potential of giving us new medicines. Also, as a general overview, if we take a look at the majority of antibiotics and anti-cancer drugs in the market now, most of them have origins from nature. So where do we look? So water is a good idea. It's a good place to look. Why is that so? Because microbes living in marine environments, they have a huge potential of giving us new medicines, especially antibiotics and anti-cancer drugs. And this is what actually inspired us. So our group was looking into addressing this global issue by looking into microbes coding for antibiotics and anti-cancer drugs. Earlier, our group, together with KAUST, we collected samples from deep Red Sea areas where there's high salinity, high temperature, a lot of metals, and low oxygen. And one of our major findings that we found the microbes were enriched with genes coding for such medicines, and also we detected anti-cancer and antibacterial effects from them. So what is the potential impact of this area of research? We're hoping to and planning to decrease the resistance problem and the deaths related to superbugs, and also introduce new antibiotics in the market to combat the superbugs. And similarly, we're planning and working on reliving medicine success, which is also the case with cancer chemotherapeutic resistance. So scientists all over the world, including us in this field, we are mining nature for new antibiotics and anti-cancer drugs with the hope to bring a brighter future and save the lives of future generations. Thank you.